So what we're going to do, normal distributions, but we're finding the value. So instead of finding the probability or the area under the curve, now we're actually going to be given the curve. So we're going to be given the curve, and we're going to have this, and they're telling us, hey, we're looking at this area right here, and we want to find that value and that value. Sometimes we may want them in z-scores, sometimes we want them in raw scores. Probably more often than not, you'll want it in a raw score, because if it's braking distance, you don't want to go to the guys who are building your cars on the assembly line and say, hey, our z-score's got to be 0.26. That's not going to make any sense to them. You change that 0.26 to braking distance and say, hey, our braking distance has to be 85 feet. That's going to make sense to them. All right, so normal distribution, finding the values. First thing we're going to do is find the z-score given the area under the normal curve. Transform that z-score back into the x value, back into our x. Find a specific data value of the normal distribution given to the probability. So those are the three things you got to do. Find the z-score according to the area. That could mean that we're using the chart to find that z-score. Could mean we're using the calculator to find the z-score. All right? I know Grant doesn't want to be writing any of this down. That'd be too much like actually being at school. Transform that z-score into an x value. So now instead of changing the x value into a z-score, we're going backwards.
I got a good grade on the exam, I probably can miss a couple numbers, can't I?
You guys see me ignoring it, right? It's just... Grant, you said you did that homework, right? You wouldn't lie to me, would you?
I wouldn't lie to you.
Look, yeah, you would. See, I know you
No,
lied to me right there. Because every time a teenager says, when I ask that question, what's the correct answer? When I say, would you lie to me?
Yeah.
Yes, I would lie to you, but I'm not lying to you
No,
right now.
I'm not.
That's the correct answer. Because yes, you would lie to
Go
me.
back to writing.
Right,
I
Mike?
wouldn't lie.
You would lie to me at some point about something.
I would.
You guys still understand I'm still ignoring.
I really would. People do, people like it.
I know. That's why when I ask that question, it always bothers me if somebody says, I wouldn't lie to you. Yes, you would.
Okay, I would lie to you, but I did the homework. All right.
That's what you should have said originally. So we want to find the z-score. We're going to take that z-score and transform it back into an x value. So a raw score, remember, x value means raw score. Feet, ACT score, SAT score, whatever it happens to be. The x value is your raw scores. Find a specific data value for a normal distribution given the probability. I think when we do this test, I might throw something on this test and maybe I'll hand back the test after you take it. And if you can find, maybe I'll say, all right, here's all the test scores. I have to think about it and set it up. Find your z-score and tell me what's the probability that somebody scored higher than you And if you can do all that, maybe I'll add like a letter grade to your actual test score or something at the end, once I pass them back, something like that, so that you can,
What if they got paid?
then I'll add something else, I'll give you some bonus for something else. You notice Dalton said, what if they got an A, right? No, you didn't say I, you said they. You said they.
Hey, first thing that goes your ears.
What?
What?
So, we were given in section 5.2, we were given normally distributed random variables, X, and we were changed them to a Z-score, and then finding the probability. This section, what we're gonna be doing, is we're gonna be going backwards of that. So we're given the probability, hey, the probability is 70%. What's the Z-score for 70%? What's the raw score for 70%? So we're going backwards. Of all that stuff that I just did up there a second ago, we're going backwards from all that. And that says the same thing as the other one. Just a nice little picture there that stuck in there. So to do this, to find Z-score given an area, determine the cumulative area to the left, use the chart to find the area, find the Z-score. Now on the chart, Michael was using my chart a second ago. What did I do with it? And he was looking out here, this is what we did, looking out here, finding your Z-score, and then going over here and find the area. Now what we're going to do is we're going to know the area, and we're going to use the chart backwards. So that's what you're doing here, is you're using the chart backwards. Using the chart backwards. Then you find that Z-score. Once you find the Z-score, so if I tell Michael the area is 0.5120 and he looks right there and he finds 0.5120, he can look right here and then look up there and say the Z-score is 0.003. That's your Z-score. Once you find that Z-score, then if we need to, we'll change it into a raw score. So that 0.003 is, this is an ACT score, or this is a braking distance in feet, or whatever it happens to be. Money earned in a quarter or whatever for the business. There's going to be a formula to change that Z-score into a raw score. There's going to be a formula, and we'll have that formula on here in a second. And we could probably actually just go ahead and write that formula right now, because you guys are smart enough that you could figure this out. For the Z-score, we have X minus mu divided by sigma. That's how we find the Z-score. Well, if we want to find the X value instead of the Z-score, all we're going to do is we're going to solve this for the X. So we're trying to get X by itself. Did this a lot in your algebra classes. What would you do first to start to get X by itself on the side? Multiply both sides by what? Sigma. You want to multiply, that's an ugly sigma, but you want to multiply both sides by sigma. So you end up with sigma times Z equals, that's a Z, not a 2, equals X minus mu. Now you add mu to both sides. You end up with,
Pardon me, teachers, for the interruption. The following students need to report to the library. Jacob Hurd, Dalton Loper, Brendan McVeigh, Mackenzie Messick, Brianna Osorio, Molly Thompson,
I wanna take your stuff
Cody
with you.
Washington, Trevor West, and Jacob Heck. Thank you.
so you end up with sigma times Z plus mu equals X. That's going to be our formula to find the X value. You just plug in those three things right there. Sigma times the Z-score plus mu equals X. Make sure you get the assignment off somebody. Cause you know, my comment when you come in here and go, well, I wasn't here cause I had to go take that test. It's gonna be, Carson didn't do his job again. And then what grade's gonna go in the grade book? That one I like, the smiley face. So if we're looking for a Z-score, if you have this chart out, I'm gonna use the chart first to do it. Find the Z-score that corresponds to that. So Michael's looking at that. Does anybody need another chart? Yes, no, maybe, can you find it?
I'll take one.
No, I need
What's that?
Who all said they need one?
Pretty sure. I think my book looks like
Good place for it. So on the chart, what we're gonna use, or what we're gonna do on this chart, is we're gonna try to find that number in all of these. Now, if we're at 0.3632, think about where you're at, so that when you're looking at this, remember, if we're here at 0, what percent of the data is to the left of 0? 50%. What percent of the data is to the right of 0? 50%. Is this higher than 50% or lower than 50%? Lower. So we're looking at something over on the left side. So are we going to be on the positive or negative side of this chart?
Negative.
The negative side. So flip over to the negative side. Michael already knew that, didn't he? So he's a mathematical genius, right? And he's going to try to find this number. Now, if you can't find that exact number, something close to it. All right? So a lot of times you're not going to find exactly that. This time we might find exactly that because I probably made up this problem to be able to find exactly that. So we look down through here. Anywhere on here is there 0.3632?
I found it.
You found it?
If you go down from 0.05 and point or 0.3, it meets up.
All right. So what's our Z-score going to be? The way you're going to find your Z-score, you're going to write down this number out here in this left-hand column, and then add on whatever's above it to that. So what's the number out to the left? Negative 0.3, is that right? And what else are we going to add on to that?
0.05.
0.05. So actually we just put a 5 right there because it's 0.05. The 3 is already in that spot. Is that right?
No.
No, it's not right?
It should be -0.25. Because you added a positive to a negative.
No, they're
Oh.
the same thing. All right, so they're both negative. You're not really adding it to it, you're just sticking it on the end. I shouldn't have said add it to it. Sticking it on the end. So that's our Z-score. So in other words, if we're looking at this curve again, you got to be able to draw these curves, guarantee. This will be a big part of the next test that we take. We know 0 is right there. Where is this Z-score going to fall at? Negative 0.35. To the left. If this is -1 right here, it's going to be somewhere about in there. So we're looking at that area right there is what we're looking at from there down. Let's see if we're right here. Did that, we drew that, that's what we're looking at. We look on the chart. 362 or 3632 there. Find our corresponding -0.3 and 0.05, -0.35 is our Z-score. Find the Z-score that has 10.75% of the distributions area to its right. So here you gotta be careful. So we're looking here, we want 10.75% to the right. So that means we're over here somewhere. Our Z-score is gonna be right there, and this is 10.75% of it. Well, our chart doesn't tell us that. Our chart tells us which direction all the time. Tells us to the left. So how could we figure out what this area is to the left over here?
90.25,
Close.
or maybe.
What do you do with that, Jesse? I know you were doing it right. You subtract that from 100% or whatever. So it actually ends up being 89.25. Is that gonna be on this chart anywhere? No. What do we need to change that percentage into? Need to change it into a decimal form. So now we're at what?
And then what you find out.
0.8925. Now you find that in the chart. Should it be on the positive side or the negative side? Which one? I heard both.
Positive.
The positive side. So it should be on the positive side.
Oh, yeah, that's right.
Because we're looking for this Z-score right here, which should be on the positive side.
8925, right here.
Found it?
0.04 and, yeah, 1.2
to C.
What is it?
1.2 and 0.
So just the 4 goes on there at the end, right? Because the 0.04, 0 is in 2 spot. Well, we already got a 2 there.
How did
So
you do that?
do what?
That one didn't make sense to me.
All right, so our chart only tells us to the left. It doesn't tell us what's to the right. Okay? This said we wanted 10.75% to be to the right. So we're looking at this right here and we're trying to find that Z-score right there. Well, that Z-score for stuff to the right is going to correspond to that same thing, but we're going to take this and subtract it from 100%. So 100% minus that gave us this. Does that make sense so far? And then once we have that, we had 89.25%. Well, this chart doesn't go by percent, it goes by decimal, so we had to bump the decimal over 2 places to get 0.8925. And then they looked on the chart and they found that number in the big area here, and found the Z-score that corresponded to it. So 0.8925, 8925 was right here. So we look over here, it's 1.2, and then a 4 on the end. That makes sense? So you gotta be careful if it's to the left or to the right, because the chart only deals with stuff to the left. See if we did it right. So we got that. That was the 0.1075. That's that area, like we said right here. But we didn't really, we couldn't really use that area, so we had to subtract it from 100. 0.8925. That's this over here. And it doesn't matter which one of these 2 areas we deal with, they're still both going to correspond to that Z-score right there. All right, just one of them has the area to the right, one of them has the area to the left. We do this, find it right there, then we look at these 2 numbers, 1.2, 0.04, stick them together. So our Z-score is 1.24. All right, let's try this one. 0.916% of the area is to the right. And again, draw this little curve just so you know what you're doing. We want 96% of the stuff to the right of our Z-score. So where's our Z-score going to be at on here? Tell me when to stop my finger. Here? A little farther this way?
I think you're wrong.
I'm at the wrong end?
It has the wrong
Yeah, I
end.
am at the wrong
It
end.
says to the right.
No, it's in the.
We want 96% to the right of where our
Oh, wait,
Z-score's
sorry, I
at.
did the, I already did that.
So
Yeah,
we're,
so it'd be, it'd be 3
we're over here?
Yeah.
Yeah.
So if I put it right here where you guys are telling me,
I don't think it's coming.
we want 96%, is that gonna be 96% of the area to the right?
Right.
I had it right.
Does everybody know this is your right, this is your left, correct?
Sure.
Is that gonna be 96% over here? No. So Dalton was right, we're over here somewhere, right? We want 96% of the area to be to the right, over that way. So what kind of Z-score should we end up with?
A big negative number.
A big negative number, right? There's no such thing as a big negative number, but sort of, right? It's gonna be something like negative 2 point something or negative 3 somewhere in that area. It's gonna be a bunch of it's on that side of it. Almost all of it's on that side. So now what we need to do is we need to take 100, take that 100%, subtract that, 96.16, somebody do that on the calculator for me.
You get 3.84.
3.84. Now we gotta bump that decimal over 2 places.
So it's gonna be 0.0.
That's our number. We're looking for that on our chart, alright? So on your chart, try to find 0.0384. If it's not on there, try to find whatever's the closest to it.
Negative 1.7.
Slow down, give everybody a chance, don't. 0.03. Looking down through here. Oh, it is on there, isn't it?
That's what I'm trying to do.
I know, but I said give everybody else a chance, don't.
Well, they all had the same chance I did.
Because you were smarter than everybody else.
Use this quicker.
So what did it come out to be? Now remember, not just 1.77, what is it? Negative 1.77, everybody agree with that? Yes, no, maybe? Does that look right? Does that seem feasible to where we were? Seems a little, like the number's not big enough, doesn't it?
No, it's big.
I thought we were gonna be at like 2 or something, a little more than 2. Yeah, it's pretty close to 2, so maybe that's right. Alright, this next one's a little tougher on this next one. So we got our normal curve. Watch on this one. Carson's watching closely. We got negative Z here. We got positive Z out here somewhere. We want to find those 2 Z-scores that have an area of 95% in the middle there. This is probably more what you would actually use if you were doing something like the braking distance, because we want 95% of all the cars to fall in this range. So we want to know the low Z, we want to know the high Z.
I know.
You know how to do it?
You subtract 95 from 100.
Good.
And that number.
Slow down, let's do that first. 95 from 100, that gives us 5, and that's point,
0, 0.
that's,
0, 0.
that's 0.05, right, as a decimal. Now what, Jesse?
Then you take half of that, and that's on each side.
Exactly. Good. So you take half that. Somebody help me out. What's 0.05 divided by 2? What is it? 0.0025. Everybody agree with that? No?
0.025.
0.025. So we're saying that this area right here that I don't have colored in should be 0.025. This area over here should also be 0.025. We only really have to deal with one of those, because if we find this Z-score over here on this side, what do we know about the Z-score on this side? It's the same thing except positive. So now what you want to do is you want to take that number, go to your chart. Are we going to be on the positive side or the negative side for this one? Negative side. So to find that negative Z, we look for an area of 0.025. 0.025. Is it on there anywhere?
Yeah. Negative 1.9 and 0.06.
So what is it?
Negative 1.9 and 0.06.
So our negative z is negative 1.96. What's our positive z gonna be then? 1.96. So those are our two. Those are the ones that we want to be in. That 1.96, important number, you're going to want to keep that in your head, because where that's at,
Is it 2 standard deviations?
it's at 2 standard deviations away. So what we're saying there is this 95%, this is 2 standard deviations below the mean, this is 2 standard deviations above the mean. That's something that we're going to use a whole bunch, and if you can just remember it, and we're going to write some stuff down with it, it'll be little keys saying, okay, if you see this, then you know this. Then you won't have to use the chart or your calculator or anything. You'll just say, oh, I know that that's negative 2 or negative 1.96, or that's 2 standard deviations below, or whatever. All right, so using the calculator to find the z-score, you might want to write this down. So we use the chart, should be able to use the chart. Since I've given Michael like 4 months and he's never going to get a calculator. We wanted to make sure we went over that, right, Michael? How to use the chart, so you know how to do it? You know how to do it now? Huh?
He forgets a lot.
Snake and jig too.
So, using the calculator to find the z-score. Use it to find the z-score. Hit the second button. Then the bars. Then you go to number 3, which is INV normal. Does anybody have a guess as to what that INV norm stands for? What's INV in math? Should have learned all this in algebra. Algebra 1, pre-algebra. What do you do when we were over here, when I was working this problem right here? How did I know to do that?
Inverse.
You do the inverse. And that's all this is. So this is telling the calculator, hey, we're not doing this normal. We're doing the inverse. We're doing it backwards. That's what INV always means in math, is doing something backwards. So the inverse of the normal curve, instead of the normal PDF or whatever we had been using, now we use inverse of the norm. We put in the area, close the parenthesis, hit enter. It's going to tell us the z-score. So let's try one. What was that last one that we just had? 0.025? Is that right? You grab your calculator, and I don't know how it works on the, we might have to write something down here for the new calculators. On the old calculator, if you got a new calculator, grab it and try it along with this and see, so you can tell me how it works. All we're going to do, we hit second, bars, go down to number 3, which says INV norm. Hit enter. You punch in the area. This is our area this time. 0.025, close the parenthesis. What's it tell us? And it goes out a little farther, right?
Yeah.
So we'll round that up to 6. Now, the bad thing with using the calculator is, was that our whole answer on the one we were doing? So you still got to remember that, hey, that was the low z-score. What was the high z-score going to be? 1.96. On the new calculators, does it work out the same? Is it the same stuff? You need the mean and the standard deviation.
It's already in there, right?
So on On the new calculator, you still do the same steps except for what is your mean and your standard deviation going to be?
0 is 1.
So you still do the same thing, but you put in those two number, and you don't need the parenthesis part, right? That's if we're just looking for a z-score. We're going to go on to other stuff where we're looking for a raw score, and then we will need the mean and standard deviation to not be 0 and 1. We'll change it to something else. All right, write this down. Very important, and this is sort of tough. Somebody didn't like z-scores, so they made up percentiles. Just another form of measuring things. It's basically like a z-score. I know Jesse's going to listen really, really closely. Whenever you see something like this where it says P and then it's got some number down here, let's talk about the 5th percentile. 72nd percentile. Don't get that confused with the P that we use for probability. This is just like the other stuff that we did earlier this year. What was the other? It was on your exam. The one that dealt with, I asked the question, what if you scored, can't remember what the units are. What if you scored, was it percentiles? What percentiles was it? What if you scored in the 90th, was it percentile? Is that what we had? So we've already done this? I don't remember doing this. If you scored in the 90th percentile, what's that telling you?
We really didn't do it. You just started 9%.
You scored higher than 90% of the people, same thing here. I didn't.
You didn't teach us, you just kept saying it so much, we kind of learned what it was.
You said it.
So, if your score is a P72, what's that telling you?
You scored above 72%.
So you scored higher than 72% of everybody that took the test. Is that good or bad?
Fairly good.
It's pretty good. Means you're better than average. What would be a average? If I could draw a normal curve, very good. What would be an average percentile? 50, right? So P50 would be right here in the middle. Anything above 50th percentile, probably fairly good, because then that means you're a little above average. We don't want to talk about Jesse's.
I'm gonna have to get it out.
P -5. Jesse, you know there's no such thing as a negative percentile, right?
Yeah, I know, that's what I was getting ready to say.
Just wanted to make sure. I was just joking with you. But it's gonna annoy me forever that you're looking at your exam score and it's for phys ed or something and you think it's for this class.
No, for real. I got an 87, which is still above average.
And then he woke up. I can't even say that he's dyslexic or anything, because a 97, if we turned it around, that's still like 40 points higher than his score.
Yeah, right. I'm just making stuff up.
So find the z-score that corresponds to P5. How would we find that z-score? What could we do? If we're on our graph, and this is, I always look at it, draw that normal graph, where's the percentile P5 going to be at? Is it going to be, I don't want to do my finger again because you guys won't stop me. You just sit here and let me look silly. Is it going to be here?
No.
No, it's going to be way down here somewhere, right?
Yeah.
Because it's way down here because we only scored higher than 5% of all the people who took the test. Well, 5% is 0.05. So if we use our calculator, this is our area this time, and we're going to use our calculator. And we said to hit second bars, go down to inverse norm, and we're just going to put in 0.05. And if you're on the new calculators, you're still using your mu as 0 and your standard deviation as 1. We hit enter, and hopefully if I'm doing this right, looks like that z-score right there should be negative 1.64. Should be somewhere around there. Does that make sense for it to be negative 0.164? Yeah, I would have thought it'd been a little closer to 2, but that's probably about right. Let's see. So we got 5% there. Same thing as I drew. Negative 1, they got negative 1.65. That's pretty close. That's if we used a table, it would come up to that. If we used calculator, it comes up to that. Z-score is about negative 1.645. It's pretty close. So be able to change those probabilities. Be able to change those percentiles into z-scores or z-scores into percentiles. So find each z-score. If we're doing this one, what's P50? What's that telling us? 50%. So it's 0.5. We punch that into the calculator. What's this one? Is it 90? So 0.90 or 0.9? 10th percentile. 0.20. 0.99.
Isn't the first one 0? The z-score.
So what would the z-score right here be?
0.
0. So that one's pretty easy, right?
Yeah.
That one's pretty easy. We really don't even need the calculator because if we draw this little thing and we're right here at 50%, we want 50% of it. The area to be down here, well, that's got to be 0. 0.9 if we use a calculator, 90%. Again, I always draw it. Just draw some little thing like this. I guarantee on the next test, if we're doing these and you draw this, I'll probably give you a point. 90% of the area,
That's about 65.
going to be about that. That's not 90%. There. Is that closer for you, Jesse? About 90%. All right. So we use the calculator, hit second, bars, inverse norm, enter, put in 0.9, close the parenthesis. Our z-score is going to be somewhere around 1.28. This one, I'm going to let Jesse come up and draw this shipment. Where's it going to be at this time?
Way to the left.
Way to the left over here somewhere. We want 10% to be below it. So somewhere about that is what it should look like. So before I even try to find the z-score, what should it come out to be? Give me a guess. This is the only reason I draw these, so that when I guess, if I punch something into the calculator,
It's like negative 1.28.
something like that, negative 1.28, somewhere
Should be about
close to that.
Should be.
All right, it should be, at least we know it's going to be a negative. So if we come up with something other than negative, we did something wrong. So z equals, we punch that in second. What are you looking at him that way for, Sean? Did he use a calculator or something? You don't believe they just did that in his head?
No, look up there. Look here, just look up.
It's the same as the
Yeah.
0.9.
Same as the 0.9?
Yeah.
It's opposite.
Ah.
It's not the same.
It's not the same?
It's the opposite.
It's just negative.
.20.
I went around it.
Same idea.
It's not raining like
If you're looking at this, .20, maybe here somewhere. Draw those each time for all this stuff. Just draw a little graph and look at it. What's it come out?
0.84 or negative 0.84.
Negative .84. How about this last one?
Oh my.
Where's it gonna be at?
2.32.
Should be way over here, right? Now, if we're at 99%, then we should be somewhere up over like 2 or 3, right? We should be pretty far out there on our z-scores. So if we hit second bars, go down to inverse norm, 0.99, end up with z equals 2.33, something like that. Can use the calculator or the chart, either one. Doesn't matter if you want to use the chart, that's fine. You just have to look up 0.5 on the chart and figure out what the z-score is, 0.9 on the chart, or use it backwards and figure out what the z-score is. I think we wrote this down, but you might want to jot it down again. If you're changing a raw score, an x, to a z-score, remember to use that formula, z equals x minus mu over sigma. If you're changing a z-score back into a raw score, then use x equals mu plus z times sigma. We wrote that down a couple minutes ago, but might not be a bad idea to have it down a second time. As a matter of fact, this formula looks a little different than the way we wrote it down. Still does the same thing, just backwards. Again, the reason we want this formula, you're not going to want to tell somebody, hey, we need the braking distance to be between negative 1.96 and positive 1.96 z-scores. That's not going to make sense to anybody. But if we can change those z-scores into raw scores, which in that case would be like feet, that's going to make more sense to the person. If you watch shows like Gas Monkey or whatever that, and you see the mechanic on there, he's a real smart guy as far as mechanics go. You go tell him, hey, you need the braking distance of this car to be between negative 1.96 and 1.96 z-scores. He's not going to have a clue.
Unless he.
You tell him that you need the braking distance to be between 115 feet and 170 feet, he's going to be able to do the braking system to work that out or to fit that.
He's all right. I could teach him a few things. TV show.
Did you hear that, Sean? Did? See, I wouldn't listen again. It's like it's a dog whistle now. I can't hear it.
What's that? You heard that? He can hear me.
What?
Close to like your ear. Neighbor's fine.
Jesse, did you get it?
Yeah.
So if we're doing this example, finding an X value, a veterinarian records the weights of cats treated at a clinic. The weights are normally distributed with a mean of 9. So this is our mu. Make sure you're watching on this. This is what your homework's going to be like. Standard deviation, this is our sigma of 2 pounds. Find the weights X of the corresponding z-scores, 1.96 and negative 0.40 and 0. So we want to do all three of those. So the first one, if we do the z-score of 1.96, first of all, what do we know about this cat if their z-score is 1.96? They're fat. All right, this is a pretty fat cat because they're on the very, very high
32
level here. Then your cat's probably not considered fat anymore. It's obese.
I put that guy.
So we got 1.96. What we're gonna do to change that into an X value is use that formula. X equals, somebody help me out, what was it? X equals, what was that formula? Change it from Z
Oh.
to X.
X equals
Mu,
Z.
Z times sigma.
Yes, sir.
So all we're gonna do is plug in here. Somebody using their calculator, help me. Mu is 9. Z is 1.96 times sigma, which is 2. What do you get when you plug that in? 12.92. So that cat should weigh about 12.92 pounds. That's a fairly fat cat. And if Chance actually has a cat that weighs 32 pounds, I'd have to see it because that's not a cat anymore. That's like a tiger.
We have one that came to work at, I think it was Thanksgiving. His name was Garfield. He weighed like 45 pounds, and he's
I'd have to see it because things like that are, if a cat's that big, number one, they can't walk.
Oh, he couldn't move. He just laid in the corner.
I could shoot that cat and have it mounted.
Next one, negative 0.44. Could you give me a guesstimate as to how much, if the cat's a negative 0.44, give me a guesstimate of their weight? 8 pounds? What do you know about it? It's gotta be below what? It's gotta be below the mean, so it's gonna be a little less than the mean, okay?
I'm gonna guess 3.8.
That would be, is that gonna be close? That's gonna be way down there. We're pretty close to the mean. So we use the same formula, X equals, our mu is 9, plus, our Z this time is negative 0.44, times our standard deviation, which is 2. Somebody do that on their calculator, help me out. 8.12. So about 8.12 pounds. So Grant was pretty close when he made that guess. What if we're at 0? What's the X value going to be?
9 pounds.
9 pounds, because it's going to be the same as the mean, because they're right there at 0 standard deviations. So that's how you change it from one to the other. This would make more sense. When you go in, and the doctors probably don't know it either, but when you go, let's say, your mom has a baby, and you go in and you look, the doctor will show you something that looks like this, and it'll have 2 X's on it for the height and the weight of the baby. And that's actually using these Z-scores about where everything should be. And they're using this line to say, instead of using a standard curve like it should be, they're using a line to show you, hey, your baby is about here on this as far as weight and height goes. So we got all that, 8.12. The last one was 9 pounds. Veterinary records the weights of dogs. They treat the weights are normally, or of dogs they treat. The weights are normally distributed and have an average of 52 pounds and standard deviation of 15 pounds. Find the weights in the Z-scores. Same thing that we just did there. So I'm not going to go through all that one. Same idea. But let's go back for 1 second. What can you tell me about this dog?
It's light.
It's a real light dog. All right. If it's 52 pounds is a fairly big dog, so if the average, this vet must treat bigger dogs probably, because 52 pounds is a pretty good sized dog. What can you tell me about this dog?
Really big one.
That's a really big dog. That's probably a little obese, and the vet's probably gonna say, hey, you need to put this dog on a diet because otherwise they're gonna. Otherwise they're gonna have. How about this dog? That's about average. A little more than average, but not bad probably. Might want to write this down.
It will work. A couple months ago.
Let me see. Russian bear dog.
Yeah, you can't wear You weigh like 300.
Write this down, Grant.
Try to keep me. He tried.
If he would, we wouldn't be having this conversation, right? I don't know, it's all we hope.
That's gonna take a big hole. And then we're gonna bury it.
See how much he needs.
So finding a specific data value, the X value, the raw score, given the area, these are just the steps that you do. And this will be the last thing that we do today. Again, very first thing, draw the graph. Draw some little graph. It doesn't have to be anything special. Just draw that little graph to let you know, hey, I'm on this side or I'm on that side, just to give you an idea. Find the percentile that corresponds to the X value. In other words, just find the area. If you're going to use the chart, that's fine. If you use a calculator, so you could put calculator here. But if you're using the chart, remember that the chart shows whatever's to the left. If you want what's to the right, then you got to subtract from 100. Find the z-score again. Could use a calculator instead of the chart. I put chart on here. You could use a calculator. You got the mu, you got the z-score, you got the sigma. Then you're going to use that formula to find the X value, the raw score. And all that part's pretty easy stuff, isn't it?
That's the last thing.
We got homework.
This is how to use a calculator to find that. So doing that same thing but using the calculator, these are the steps. I'll give you a second if you want to write that down. It's sort of the same. Again, the new calculator. On the new calculator, you just have to put in the mean standard. It's still the same thing, it just doesn't look quite the same. The old calculator, you hit second bars 3, put in the area, comma, put in the mean, comma, put in the standard deviation, close the parentheses, hit enter. The new calculator, you do all that same stuff, put in all those things, and then you'll have to just hit enter and then enter again. So down here for the new calculator, you're going to hit enter right here, and then you're going to hit enter again. So all this stuff, you could just use your calculator on all this stuff. You don't have to use the chart. You don't have to use all the other stuff that we were doing. The calculator will do it all for you, but you got to remember how to do it. And make sure you understand what you're actually doing when you're using your calculator.
What's the homework?
I'm getting ready to tell you here in a minute. As soon as I yell at Grant for having that phone out again.
That was not
All right, the assignment's on page 262. Please don't forget on these. First thing you should do on all of them is do what? Draw that little standard curve and figure out where you're at. That way you can say, okay, I'm here. Well, my z-score should be negative 1.2 or somewhere close to that. Figure out about where you're at before you just get the wrong answer.